When installing a new lighting fixture in conjunction with existing sconces, several approaches can ensure safety and compliance with the National Electrical Code (NEC). The primary concern is avoiding overcurrent issues, which can lead to hazards. The first option is to install the fixture on a separate circuit. This is often the recommended solution as it minimizes the risk of overloading any single circuit. Begin by identifying an available circuit in the electrical panel or installing a new one if necessary. Ensure the circuit breaker or fuse for the new circuit is appropriately sized for the fixture's maximum amperage draw. The fixture's specifications should provide this information. The circuit should have sufficient capacity to handle the fixture's load without exceeding 80% of the breaker's rating, a key NEC requirement. A second option involves derating the existing circuit that powers the sconces. This means reducing the allowable load on that circuit. Begin by calculating the total wattage of the sconces. For instance, if you have 3 sconces each rated at 60 watts, the total wattage is 3 times 60, equaling 180 watts. Next, determine the maximum wattage allowed in the circuit. This is based on the circuit breaker or fuse rating. For a 15 amp circuit at 120 volts, the maximum wattage is 15 amps times 120 volts, equaling 1800 watts. However, NEC guidelines state that the continuous load should not exceed 80% of the circuit's rating. Therefore, 1800 watts times 0.80 equals 1440 watts. Subtract the total wattage of the sconces from the maximum allowable wattage to determine the available wattage for the new fixture. In this case, 1440 watts minus 180 watts equals 1260 watts. Choose a fixture with a wattage that does not exceed this available wattage. Note that the rating may require replacing the circuit breaker or fuse with a lower amperage rating to ensure adequate protection. Always verify that the wire gauge is appropriate for the new breaker size. A third option is to use parallel wiring. This involves connecting the fixture to the same circuit as the sconces but adding a separate branch circuit for the fixture. Install a junction box near the fixture location. Run a new cable from the fixture to this junction box, creating a separate branch circuit. Connect this branch circuit cable to the main circuit within the junction box. This method effectively creates a parallel connection, distributing the load. It is important to note that this option requires an additional branch circuit breaker or fuse and can be more involved than the other options. When implementing any of these options, several NEC compliance considerations are crucial. A total load on any circuit must not exceed 80% of the circuit rating. This is a fundamental rule to prevent overloads. The branch circuit cable and circuit breaker or fuse must be sized appropriately for the maximum amperage draw of the connected devices. Use NEC tables such as Table 310.15b16 to determine the correct wire gauge for the amperage. All wiring and connections must meet NEC requirements for safety and proper operation. Use approved wiring methods, ensure proper grounding, and make secure connections. The NEC provides detailed guidelines for these practices. Here's a more detailed breakdown of how to approach these installation options. Firstly, installing the fixture on a separate circuit is often the safest and more straightforward method. Begin by locating your electrical panel and identifying any available circuit breakers. If there isn't a spare breaker, you may need to install a new one, which might require professional assistance to ensure it's done safely and in compliance with local codes. Once you've identified or installed a new circuit breaker, ensure that its amperage rating is appropriate for the new fixture. Check the fixture's specifications to determine its maximum amperage draw. For example, if the fixture draws 5 amps, a 15 amp circuit breaker would likely be sufficient, but always factor in the 80% rule. This rule dictates that you should not load a circuit to more than 80% of its capacity to prevent overheating and potential fires. So, for a 15 amp breaker, the continuous load should not exceed 12 amps. Run a new cable from the electrical panel to the location where you want to install the fixture. Use the correct gauge of wire for the circuit's amperage. Again, NEC Table 310.15b16 provides guidance on this. Secure the cable properly along its route, using staples or other appropriate fasteners to keep it in place and protect it from damage. Connect the cable to the fixture following the manufacturer's instructions. Ensure that all connections are tight and secure. Use wire connectors that are rated for the wire gauge you are using. Ground the fixture properly, connecting the ground wire to the grounding terminal in the fixture and to the grounding busbar in the electrical panel. This is crucial for safety, as it provides a path for fault current in case of a short circuit. Secondly, derating a circuit involves reducing the amount of load you place on an existing circuit to accommodate the new fixture. This option is viable if you cannot easily run a new circuit but requires careful calculations to ensure you don't overload the existing one. Start by determining the total load already on the circuit. This includes the sconces and any other devices powered by the same circuit. Calculate the wattage of each device and add them together to get the total wattage. For example, if you have 360 watt sconces and a 100 watt lamp on the same circuit, the total wattage is 3 times 60 plus 100, equaling 280 watts. Determine the maximum allowable wattage on the circuit. As mentioned earlier, for a 15 amp circuit at 120 volts, the maximum continuous load should not exceed 1440 watts. 15 amps times 120 volts times 0.80. Subtract the existing load from the maximum allowable load to find the available wattage for the new fixture. In this case, 1440 watts minus 280 watts equals 1160 watts. Choose a fixture with a wattage that is less than or equal to the available wattage. If the available wattage is too low, you may need to replace some of the existing devices with lower wattage versions to free up more capacity. If the existing circuit is protected by a circuit breaker or fuse with a higher amperage rating than necessary, you may consider replacing it with a lower amperage one. However, this should only be done if the wire gauge is appropriate for the lower amperage and if it complies with NEC regulations. For example, if you have a 20 amp breaker on a circuit with 14 gauge wire, you should not replace it with a 15 amp breaker, as 14 gauge wire is typically only rated for 15 amps. Thirdly, using parallel wiring involves connecting the new fixture to the same circuit as the sconces, but in a way that each has its own branch circuit. This method can be more complex but allows for greater flexibility in load distribution. Install a junction box near the location where you want to install the new fixture. This box will serve as the point where the new branch circuit connects to the existing circuit. Run a cable from the existing circuit to the junction box. This cable will provide power to both the sconces and the new fixture. Inside the junction box, split the incoming power into two separate branch circuits. One branch circuit will continue to power the sconces while the other will power the new fixture. Use wire connectors to make the connections, ensuring that each connection is tight and secure. Run a separate cable from the junction box to the new fixture. This cable will carry power from the junction box to the fixture. Connect the cable to the fixture, following the manufacturer's instructions. Ensure that all connections are tight and secure. Install a separate circuit breaker or fuse for the new branch circuit. This will provide additional protection for the new fixture and prevent overloads on the main circuit. The amperage rating of this breaker or fuse should be appropriate for the fixture's maximum amperage draw. Finally, regardless of which installation method you choose, always keep the following NEC compliance considerations in mind. The total load on any circuit must not exceed 80% of the circuit rating. This is a fundamental rule to prevent overloads and ensure safety. The branch circuit cable and circuit breaker or fuse must be sized appropriately for the maximum amperage draw of the connected devices. Use NEC tables to determine the correct wire gauge for the amperage. All wiring and connections must meet NEC requirements for safety and proper operation. Use approved wiring methods, ensure proper grounding, and make secure connections. Here are some additional points to ensure a safe and compliant lighting fixture installation. Firstly, always turn off the power to the circuit before working on any electrical connections. This is the most important safety precaution to prevent electric shock. Use a voltage tester to verify that the power is off before you begin working. Secondly, use the correct tools for the job. This includes wire strippers, pliers, screwdrivers, and a voltage tester. Using the wrong tools can damage the wires or create unsafe connections. Thirdly, follow the manufacturer's instructions when installing the fixture. The instructions will provide specific guidance on how to connect the wires and mount the fixture. Fourthly, make sure all connections are tight and secure. Loose connections can cause arcing, overheating, and even fires. Use wire connectors that are rated for the wire gauge you are using and tighten them securely. Fifthly, ground the fixture properly. Grounding provides a path for fault current in case of a short circuit, which can prevent electric shock. Connect the ground wire to the grounding terminal in the fixture and to the grounding busbar in the electrical panel. Sixthly, protect the wires from damage. Use staples or other appropriate fasteners to secure the wires along their route and protect them from abrasion or physical damage. Seventhly, inspect your work carefully before turning the power back on. Make sure all connections are tight, the wires are properly secured, and the fixture is properly grounded. Eighthly, test the circuit after turning the power back on. Use a voltage tester to verify that the circuit is working properly and that there are no shorts or open circuits. Ninthly, if you are not comfortable working with electricity, hire a qualified electrician. Working with electricity can be dangerous, and it's always best to err on the side of caution. A qualified electrician will have the knowledge and experience to install the fixture safely and in compliance with all applicable codes. Tenthly, keep the NEC code book handy. The National Electrical Code is a comprehensive set of standards for electrical installations, and it's essential to be familiar with the requirements that apply to your project. The NEC is updated every 3 years, so make sure you are using the latest version. 11th, local codes may have additional requirements. In addition to the NEC, your local jurisdiction may have its own electrical codes that you must comply with. Check with your local building department to find out what these requirements are. 12th, consider using arc fault circuit interrupters, ASIs. ASIs are a type of circuit breaker that can detect arc faults, which are a common cause of electrical fires. ASIs are required in many areas for new construction and renovations, and they can provide an extra layer of protection against electrical fires. 13th, use surge protection devices, SPDs. SPD can protect your electrical equipment from damage caused by voltage surges, such as those caused by lightning strikes. SPD are available in a variety of forms, including whole house surge protectors and plug-in surge protectors. 14th, label your circuit breakers. Clearly label each circuit breaker in your electrical panel so you know which circuit it controls. This will make it easier to turn off the power to the correct circuit when you are working on electrical connections. 15th, keep your electrical panel accessible. Make sure your electrical panel is easily accessible in case of an emergency. Don't block it with furniture or other items. 16th, have your electrical system inspected periodically. Have a qualified electrician inspect your electrical system periodically to identify any potential problems and ensure that it is in good working order. 17th, when running wires through walls or ceilings, use appropriate conduit or cable protection. This will protect the wires from damage and prevent them from coming into contact with flammable materials. 18th, use junction boxes for all electrical connections. Junction boxes provide a safe and secure enclosure for electrical connections and protect them from the elements. 19th, when working with aluminum wire, use connectors that are specifically designed for aluminum wire. Aluminum wire expands and contracts more than copper wire, which can cause loose connections if the wrong type of connector is used. 20th, if you are unsure about any aspect of the installation, consult with a qualified electrician. It's always better to be safe than sorry when working with electricity.